Good morning, one and all present over here. I would like to thank the conference team for giving me this opportunity. So, I'll start my presentation. Basically, my topic is epileptic seizure detection and prediction using machine learning and deep learning. Under the guidance of Dr. Kalpana Thakre ma'am, she is a professor and Dean R&D, MMCU, SPPU, Pune. So, basically, this is my PhD topic. I would like to what this epilepsy is. So, epilepsy is one of the neurological disorder characterized by the abnormal electrical discharge inside the brain. So, it is an uncertain activity, which we are calling it as epilepsy. And there are different neurological disorders, out of which I have choose this epilepsy because as there is no maximum research has been done on this. So, to address these problems, this epilepsy detection is important as per the clinician's point of view. So basically, this epilepsy can be monitored or can be observed through the EEG signals. So electroencephalogram, these are nothing but the continuous EEG monitoring of the brain through which we can point out whether the person can have a seizure in future or not. And if that is so, so there are the different states of the epilepsy, like there are the ictal, pre-ictal, post-ictal states. So if we can observe this in advance, which we are calling it as forecasting or prediction in advance, we can have some kind of the treatments initially to avoid the uncertainty of some health issues related to some persons or human beings. So keeping that in mind, this epilepsy detection is very important. So basically, more than 50 millions of the people in the world affected by this epilepsy. So the primary source for detecting or predicting whether the person is affecting from the epileptic seizure or not is through the EEG. So this EEG, as I have said, it is nothing but the recording of the brain. We can record it using the electroencephalogram. So that is the primary source for the abnormal electrical activity. So as clinicians are observing this brain activity manually, as this manual process is somewhat time consuming and may prone to error. So to deal with this, we can have, as there are some machine learning and deep learning advancements, so we can have some kind of the a model which will predict based on the historical data, based on the historical information of the patient. We can have seizure prediction in advance to save someone's life. So based on that, seizure detection is one of the thing and seizure prediction is one of the thing. So seizure detection, as I have said, like this epileptic seizure, that comes under three states, like ictal, pre-ictal and post-ictal. So ictal states identifies whether the person is dealing with seizure or not. So identifies the ictal state means that is a real time when the epileptic seizure occurs. And prediction, that is nothing but the forecasting of an event before some time. So as I have developed a model where I have kept the window size of some 30 minutes before the time, whether we are able to, based on the historical data, whether we are able to predict or forecast in it in advance. So that term we are calling it as the seizure prediction, that is forecasting and impeding seizure before the onset of the seizure. So that gives a timely warning or the intervention to the clinicians or to the caregiver of a patient to deal with certain kind of the seizure and to deal with the patient or to handle the patient. So the main motivation behind this epileptic seizure detection and prediction is to uh, accurate and automatic clinically useful EEG analysis and help the patient to forecast epilepsy in advance. So this there are the different research has been carried out over the years, but some of the current methods which suffers from these problems, like noisy EEG, as there are the brain recordings, there may be different kind of the artifacts like eyes open, eyes closed. Likewise, so noisy EEG, redundant features, as there is a continuous brain recording. So some of the features are redundant, that may be not needed at the time of the detection. High dimensionality, obviously, as these are the EEG signals which comes under time and frequency domains. So some of the features are very high dimensional, and as there are the limitations like CPU only we are working on the model, so that high dimensionality, that is again one of the problem which can be resolved using the GPUs, high computational cost and lack of real-time GUI. As the clinicians nowadays manually handling over the monitor, if we have some kind of the GUI-based application, which where we have provided the historical data that may help the clinician to detect or to predict whether the patient may suffer from the seizure, likewise. So to address these problems, some of the literature I have already done, where I have found out which kind of the MLDL model they have used and what exactly the results they have found. Some may be providing better accuracy, but some may lack in the sensitivity and some may lack in the latency. So to deal with these problems, we can have a different kind of the machine learning and deep learning models like convolutional neural network, graph neural network. But as this convolutional neural network, it is mainly focusing on extracting the spatial features, but it is not extracting the temporal features. As all the epilepsy seizure detection and prediction is all based on EEG signal only, which comes under time and frequency domain. So this time and frequency domain features for exactly detecting and predicting the seizure, we need to keep in mind that only the spatial features are not important, but will require the temporal features too. So I have proposed a solution on this CNN. Instead of using only the CNN, we can use the spatio-temporal attention as one of the solution, which will focus on spatial as well as temporal features, and which will give us the exact feature for reducing the false prediction. Again, there are the graph convolutional network existing. Some of the papers were using, but to reduce the feature diversity and better classification, if we have taken the spatial and temporal features, all that hundred or thousands of features may not be needed all the time. So there will require the AMBO optimization. So this AMBO optimization means enhanced multi-objective beam optimization. So if we have taken thousands of the features from spatio-temporal attention, all that thousand features may be redundant. So to take only the important features, this AMBO selects most informative features. That is my proposed solution. Again, once we have taken this some of the important feature, next is nothing but the hierarchical dual Q learning. So this hierarchical dual Q learning, what it does the important feature, it takes the important features, and from that important features, it learns from the adaptive learning, and it gives us whether there is a seizure or not, or means it classifies whether there is a seizure or not. Again, this hierarchical dual Q learning. So dual Q means it works in two Q states. Like Q1, it identifies the seizure, and Q2 state, it is means it is confirming that yes, there is a seizure. It is once again confirming that from the basis of on the basis of the hierarchical data. So I have done this research on basically a publicly available data set, that is CHB MIT data set. Again, I have used two additional data set for the comparison and evaluation purpose, like Bond data set and TUH Temple University data set. So this is my proposed methodology, where this is nothing but the input like the EEG signal. This EEG signal is nothing but which we are capturing through the EEG cap, and this EEG cap is having 23 channels like CH1, CH2 likewise. Once I have considering this, that CHB MIT dataset, publicly available dataset, it is having 23 channels. I have collected, this is the input. Once I have taken this EEG data, again it is pre-processed, because as there are the artifacts, there are the noise too. So for removing of that artifact and noise, that needs to be pre-processed. Again, once it is pre-processed, I need to consider both spatial and temporal EEG features. Once I have used ST attention, I have selected some of the features, important features from that using EMBO method, that is enhanced multi-objective beam optimization. And this multi-objective beam optimization then given to the HDQL for further classification whether there is a seizure or not. And all this I am carrying out using the GUI platform. So this is only the EEG-based seizure analysis pipeline, how exactly the acquisition, pre-processing, presentation using MLDL models, and out of which that is preictal and ictal states for detection, identifying the seizure, and prediction, warning before, that is forecasting. So this is simply the description of the data set, as I have basically first tested on the CHB MIT SCALP EEG data set of 23 patients. Further, I have for comparison and evaluation, I have extended my study to Bonn EEG data set and Temple University EEG data set. So this is simply the mathematical flow of my study: spatio-temporal attention, EMBO algorithm, which is taking some of the relevance object features, like on the basis of relevance, on the basis of redundancy, on the basis of number of features, it is taking some of the features. And once I have collected important features, next I am applying the HDQL learning algorithm, where as this is double Q or dual Q learning hierarchical algorithm, where there are the two states Q1 and Q2, where first Q1 it selects the action, means it detects whether there is a seizure or not, and Q2 it evaluates the action, means it confirms the seizure to reduce the false alarm, because at the end we are providing the output on the basis of the confusion matrix. So this is the screenshot of the GUI which I have designed for this. So this is the GUI which I have designed using the Flask API on the local host. I have just running it. I have just put it the screenshots of this. I can select a specific data set, and I can perform the detection prediction, and where I can get the report on the basis of accuracy, sensitivity, specificity. This is how exactly the prediction looks like. So prediction, I have given the 30 minutes window before the onset of the seizure. It will give me the alarm, which will help the clinician or to the caregiver that to take the attention or to look towards the patient. There may be the possibility of the seizure. So this is the result I have received for the for the detection, and this is for the prediction. So this result I have received on CHB MIT database, on Bonn University, and on TUH dataset. So at the end, I would like to conclude that this model which I have designed for epileptic seizure detection and prediction, it is using spatio-temporal attention mechanism, it is using EMBO algorithm, and it is using dual Q HDQL algorithm for better seizure detection and confirming that yes, there is a seizure on a specific EEG data set. So I have applied, or I have tested this model on 3 different data sets, and I have received a better accuracy compared with the existing algorithms. So thank you all. Thank you so much.